Algebra 1, here we are, working our way through chapter 11. We are on 11.4 today. I think many of you will be happy to see 11.4 is the Pythagorean theorem. You should be pretty familiar with this. This is not your first exposure. You've had this several times. Of course, we're going to take it to the next level with you, and you're going to do a little bit more with some of the basics. But thankfully, it starts out fairly simple with some things you should be familiar with. If you're not, I'm going to go ahead and review very quickly. Okay, you missed my great drawings, I know. So we're going to start the Pythagorean theorem. Always has a right angle, all right? We call these the legs of your triangle, and always this side is called the hypotenuse. If you don't have paper and I'm sure an erasable pen, none of you would do this in pen or pencil, I suggest you take notes. It's good practice. Keep it up. I know you're home. Maybe mom or dad don't sit and require you to, but it's good practice. Okay. So when you have a right triangle, the side opposite would be this long angled side. That is called the hypotenuse. Okay. The legs are A, B. That is C. And hopefully at this point you're like, oh yeah, the Pythagorean theorem. A squared plus B squared equals C squared. That should be familiar to you, hopefully. I know we've seen that before. So let's talk about what we do with that. Look on page 737. Again, I'm going through section 11.4. I'm not going to work through all the examples because you can see them there. So instead, let's go ahead and look at guided practice number 1. At the bottom of the page it says, and again I get this lovely triangle, so good. The legs are 5 and 12, find C. Okay, I'm using my Pythagorean theorem. I'm going to go 5 squared plus 12 squared. Wow, getting ahead of myself. Will equal C squared. Okay, 25 plus 144 will equal C squared. Okay, and most of you recognize 169 equals C squared. Now some of you get a little careless in doing these last parts, so just remember, to find C, I take the square root of both sides. And the square root of 169 is 13. That's my side length. Okay? That's my hypotenuse length. Excuse me, not my side. My sides were 5 and 12. Okay? That's probably fairly familiar, straightforward. Yes, you know that. That'll be the easiest part of your assignment for sure. Turn over to page 738. We're going to look at example 2. How do we use the Pythagorean theorem? Again, they give you an example there, and they walk through that. I am going to go ahead and work on guided practice because you don't have the examples and the answers for that. So I'm going to work through one that you do not. So we're going to do guided practice number 2. And it says a right triangle has one leg that's 3 inches longer than the other leg. The length of the hypotenuse is 15. Find the unknown length. Okay, so this is where you're going to use more algebra. You're going to use a little bit more higher level thinking in solving this process. Okay, it tells me that one leg is 3 inches longer. So since this is longer, I'm going to call that x. Say this is x plus 3. And they tell you that the hypotenuse is 15. Okay. Well, then I have to recognize a squared plus b squared is c squared. Okay. Remember, x plus 3 squared, right? We're going to do x plus 3 squared. Looks like this. wow, we have to remember how we FOILed and all of that. Yes, I'm sorry. I'm sorry you do. So, first, x squared, outside, 3x, inside, last. All right, and then we're going to simplify that. So, a squared plus b squared is c squared. A squared looks like this. X plus 3 squared looks like x squared plus 6x plus 9 equals c squared. Okay, hopefully that's somewhat straightforward to you. Now what we do here is start combining terms. All right, we have x squared and x squared, which is 2x squared. Remember, you're only adding coefficients. You don't change the exponents. 2x squared plus 6x. Now, I'm going to go ahead and combine two steps here. 15 squared, hopefully, you can recognize 225, right? So that 225, I want to get on this side of the equation. All right, so I'm going to subtract it here. I'm going to subtract it here. And I get 9 minus 225 is a negative 216. Okay? We have done that before in solving quadratics, okay? All I did was square this, recognize that I have to subtract it to have it cancel. I do it to both sides. Now what? Okay? Factor out my 2. X squared plus 3x, and then I'm going to get minus 108. Great. Should remember factoring, simplifying. Again, I'm going to take my next step and go to 2 parentheses. I have x, got a factor here. What do I multiply to get 108? That if I add together, I get 3. So you're going through your factors of 108. You could start with 2, but you're not going to get numbers. That'll be 54, and there's no way you're going to get 3 from 2 and 54. So you can continue to do that process. You can try 4. That'll give you 27. That's not going to give you 3. But as you work down your list of factors, because you're all great at math facts at this point, all right, I'm going to recognize that 12 times 9 is 108. Realizing I need a positive number here, this has got to be bigger. Plus 12 minus 9. Okay? Again, 12 times 9 gives me 108. 12x minus 9x gives me 3x. So I don't worry about that too. In solving this, I get x equals 9 and x equals negative 12. Now, you're going to see in this how it works out, but you have to recognize when you get this answer for x, is it possible for a side length to be a negative 12? No. And it's math. You have to do things that make sense. So you can't just go, oh, it must be positive 12. No, that doesn't mean that you just flip a sign, okay? What it means is this is not x. You cannot have a side length of a negative number. What you can see is that if I go back here and call x 9, then realize 9 here plus 3 does give you 12, okay? You will have to try these. You won't always have, sometimes last chapter you learned that they're called extraneous solutions. Sometimes you will have solutions that don't fit into what your scenario is. Negative 12 is one of those numbers. Now, it does happen that this turns out to be 9 plus 3, and you get 12 for your values here. So it would be 9 inches and 12 inches. A good math student, you should go back and check it. And you will find 81 plus 144 does equal 225. That works. Okay? So, that is how we'll use it in a more complicated problem. Write this down. Have this as an example for you. Again, you have an example in your book. This was guided practice 2. Those answers aren't listed for you, but now you have something else to look at, to study, okay? That is how you will solve it using the Pythagorean theorem and a little algebra background that you have. Example 3, again, they give you an example in the book on page 738. Standardized test practice problem. I'm going to go ahead and do a guided practice with you because you don't have the answer for that. So you have one more opportunity to look at a problem. Let's do guided practice 3. On page 738 it says a rectangular pool is 30 feet wide, 60 feet long. Here we go. You swim diagonally across the pool to the nearest foot. How far do you swim? Not so bad. 30 squared plus 60 squared has to equal x squared. 900 plus 3600. Okay, you can see all that. 4500 equals x squared. To solve this, when you take the square root of 4500, you're going to get something like 67.08. It says to the nearest foot, so you should pay attention to that and realize they're asking you that x is 67 feet to the nearest foot. Great. That's typical. You will probably see things like that on a standardized test. Last one, example 4, determining right triangles. Okay, here's where you're using what they call the converse of the Pythagorean theorem, meaning to find out if it's true, if it is a right triangle, a squared plus b squared has to equal c squared. Okay, so when you look at those, you use the links they give you to determine, well, is it for sure a right triangle? All right, I'm going to look at, on page 739, let's look at number 4. Okay, they give you on guided practice, page 739, number 4. They give you 7, 11, and 13. Knowing a squared plus b squared is c squared. Yes, you have to have that memorized. Not too hard. Probably one of the easier algebra assignments you get. All right, 49 is 7 squared. 121 is 11 squared. Does that equal 169, which is 13 squared? Adding these up, 170. And I want you to make sure you learn these symbols here. Is that true? That is not equal. Put that slash through the equal sign. That is not equal, so no, that's not a right triangle. Looking at number 5, 15, 36, and 39. Okay. A squared plus b squared is c squared. So 15 squared, 225. 36 squared is 1296. Just in case you wondered, I had that written down. I didn't do it in my head. 39 squared is 1521. 1521. Add all those up. 1521 does equal 1521. So the answer is yes. Now, if Mrs. Winfrey, your algebra teacher, needs to write down some work to solve a problem, so do you. Do you have to write every single thing? Not necessarily, but I want to see more than just these numbers and yes or no. I want to see that you've computed that and what your answer comes out to be. Last one we're going to look at is number 7. So let's look at guided practice number 7 on page 739. And you're going to see how easy these story problems are. The ones you kind of freak out about, these word problems are not terrible. Window design. A window has the shape of a triangle, side lengths of 120, 120 and 180. Is it a right triangle? Well, that's pretty simple. It's really just what we just did. Let's look at this window, except probably should realize your triangle, okay, it's shape of a triangle, looks like that. And your hypotenuse would be over here, always across from the right triangle. How do you solve it? 120 squared, okay, plus 120 squared is 180. 120 squared is 14,400. And I'm going to just go times 2, right? 180 squared is 32,400. 2 times this ends up being 28,800. 32,400. Okay, so what we know is that is not equal, so this is not a right triangle. Okay, that would not be a right triangle. And it wouldn't be the way I've drawn it either. So we're good. Hopefully that's pretty straightforward. If you have questions, you know where I am from 2 to 3 today, Google Meet. That is on RenWeb. That's also in Google Classroom, I believe, if you need to come talk to me. Google Meet from 2 to 3, and I have that time set aside just for your class, so I don't have other kids that I have popping on there to ask questions as just for you guys. So 2 to 3 Google Meet if you have any questions. Hope it goes well.